Hey everyone, let's take a quick look at how Latent Assisted Label can automatically discover, detect, and organize objects in synthetic urban imagery, turning raw data into structured insights within just minutes. I'm starting here with a small synthetic dataset, as you can see here. They're just some overhead urban scenes. I've generated some from Omniverse using NVIDIA, and also some from open source datasets I found online. The goal is to explore what's inside these images and automatically discover and label objects of interest, all without manual annotation. I'll begin with our unified detection operator in the tool. This basically combines two complementary modes. It uses find description, which runs a VLM to search for specific objects. Here, let me ask it to find all cars in the scene. Then, inside advanced settings, you can see that there are other options to configure from. Let's say we're doing data discovery and want to find new objects that are in the dataset. So let's run the mode with both. This will also use find everything. And find everything uses a foundation model to detect every other object visible. It could be buildings, trees, roads, signs, and anything that the model can see. Let's configure some of these settings here. We can set what the maximum size of the object will be, what the minimum size of the object will be, and we can also control how noisy the image is going to be. So we can set these as 0.3 and 0.3. These results will be finally merged into one single field called Unified Detections, and each object is embedded into a shared feature space for downstream analysis. Now here, once we just click execute, you'll see it run and the detections will show up on the side. Here I've already pre-run the detection process. It takes a few seconds to run, and you can see that it proposes a bunch of candidate objects. As you can see, like in a single pass, we have identified various objects, we've identified cars, we have uncovered other meaningful elements in the data. We can also review these detections. Let's open the patch level view here. As you can see, each of these objects are present here. I can visually review them. I can filter by size or confidence. I can remove irrelevant boxes or rename labels. This part is very fast, interactive, and keeps me in control, where the AI accelerates labeling while I ensure quality. We also have an easier interface to actually do this. We run something called find similar. As you can see, there's an operator called find similar here, which basically clusters objects into using their embeddings. It groups visually similar ones together and pushes dissimilar ones apart. Once I've scheduled this process in the back end, you can see that it will run and populate in the embedding view here. In the embedding view, you can see that the different objects have been discovered. On the legend on the top right, you can see there are cars and unknown objects. Let's lasso around a few of them to see what they look like, and also open a side-by-side view here with the data. I can quickly lasso around a few clusters. As you can see, there are parts of the lawn here. Let's lasso around some other section here. You can see there are a bunch of windows all grouped together. Let's see what's in this corner. We have more windows in that particular cluster group. Let's see what's here. You can see that there are various trees in this cluster group, and so on. The idea here is we can go into each of these cluster groups and we just label a few examples after manually reviewing them. We can go into modify detections here. We click on adding a new label, and we can enter a custom label that we want. Let's call it lawn. And we can apply it for the existing view alone and hit execute. Once this runs, this will update, and we can manually go through this for a few objects. We can just label 4 or 5 objects within a single class, and let the system handle the heavy lifting to find all other similar objects. I'm going to open a sample which is already run here real quick. Okay, here you can see we have the same data set where I have gone through as an expert in the loop. I have labeled a few objects and I have run find similar to do the heavy lifting. Once I open the embedding view real quick, as you can see, open a side-by-side view with the other objects. You can see a bunch of object detections here. Let's go into unified detections, and now let's see how the clustering looks like. As you can see in the legend in the top right corner, we have a bunch of objects. We have cars, we have crosswalks. Let's go through each of these cluster groups. Let's see, all these are like crosswalks. Let's look at the section here. They're all lawns as per the legend. Let's see what's on the left corner here. We see a bunch of shrubs from the overhead view. You can also double click on the legend here to look at cars alone. Going into the car cluster here, you see there are a bunch of cars that are picked up. And this is where the expert comes into the loop. You can see that these are within the car cluster. You can actually go in and make changes yourself. You can always go back to adjust labels, merge clusters, or remove detections, and this is where the expert in the loop refinement happens. As I go in, I also have the option to modify detections, and I can remove detections that I don't care about, and all I have to do is click on execute. In just a few steps, you can see how easy this labeling process is. You can just look at a few more objects present here. In just like a few steps, we have used the tool to discover, detect, cluster, and label synthetic overhead imagery automatically. And what this tool enables us to do is very simple data exploration. It lets us go from data exploration all the way to structure annotations, all powered by simple foundation models under the hood. This is basically AI-powered data discovery, going from unlabeled pixels to structured insights in just minutes. You can export this data set into the format you wish to use, and then you can go ahead and use our agent for downstream processing.
Visit our site to see how Latent Label is revolutionizing data discovery and annotation.